Hello everyone. Can you hear me and see me properly? And can you see the slides? Cool. So today I'm gonna continue on what we were working on yesterday. Basically, let's get to the basic setup that we were having, and then we'll walk through some of the code and the repo that I shared. Hopefully, some of you were able to run the GitHub project that I shared yesterday and play around with it. We'll dive a little bit deep into that project and try to understand how to actually create a GraphQL server and what goes into there. So let me just go before we start. Let me just do a quick overview of what we went through yesterday through these slides, and then we can start new topics. So I'm just gonna start with the basic setup that we were discussing yesterday. We have a client and a server. Our server is a movie service, which we first looked at it from a REST lens with a movie DB, and then we discussed about how can we filter certain movies based on query parameters, which was like uh, the first, which was also kind of a motivation to GraphQL. I think it has an equivalence in GraphQL. Then we discussed about why the query param is not enough, and how can we actually filter the attributes coming from the backend. And we use the post method with the payload itself to notify the server that the client only needs certain attributes. Uh, the problem with this approach was there was no standardization. The client and the server needs to constantly communicate and establish a contract, and it does not scale. Um, that's where we introduce GraphQL, where the client, if you see on the top, defines a query to the server, and the server responds with the data in exactly the same as the query. Then we discussed about how in a GraphQL we can ask for multiple things to the server, not just one operation. We can execute multiple operation. Then we looked into the actual GraphQL spec. This is what is important. We have three things: query, operation, and variables. The query itself has the actual GraphQL query. The operation is either query or mutation, and variables are variables that you possibly can use in the query. We saw some examples of variables yesterday as well. Um, then we discussed about what a GraphQL query and schema is. If you see on the server side, the server defines a schema. On the client side, the client asks for data using the GraphQL query, and the data returned is in the same shape as the schema or the query. Uh, so I think then we discussed we saw some examples of the movie service itself, and we went through the Apollo Studio and the swappy GraphQL API, which was readily available, and saw some examples. Hopefully you guys were able to play with this API as well, so that you could get your hands dirty with actually querying the GraphQL service. Okay, today I will start with the way of actually creating a GraphQL service and what goes into creation of a GraphQL service. If you understood yesterday, everything in the GraphQL world revolves around the schema itself. Schema is like the backbone of what a GraphQL system looks like. It defines the shape of the query, it defines the hierarchy, and it defines the uh, it defines what each attribute means at the until the leaf level, and that's what the clients and tools are basically built off of. So how do you translate this schema into a runtime implementation? How does the server implement this at runtime? If you if you have created a REST server using Express or Spring Boot, usually the REST server has a controller, and the controller has like methods like get, put, post, delete, and you have query params and stuff. And then the REST server, whenever a request comes to that REST server, it delegates it to the controller using the matching method and the content type and the accept type, and sends it to the correct controller. The controller now hosts your code, which actually executes the business logic for your REST server. In GraphQL, like I said, there's only always going to be a /GraphQL endpoint and only going to be a single endpoint. Everything is defined in the query. The query has operations, and that's what actually is required. And the equivalent of controller in GraphQL is something called as resolvers or data fetcher. It's called data fetchers in the Java world, but actually if you look any of the GraphQL docs, it will be called resolver. So it's very simple. It's not very complicated. The queries, the resolvers also should follow the same shape as the query itself. If you see the example on the right, there is an example of a resolver using Netflix DGS library. That is a popular library that all Java developers use to write their GraphQL service. And it's a very simple implementation. There is a DGS component annotation on top of the class, and we just auto wire any kind of beans that you want, and then you implement a DGS query which matches the schema. If you see the method, I think there's a typo in here. It should not return pet, it should return a movie. But if you see the movie method, it takes an input argument called ID, which matches exactly like the schema, and the object return should be movie ideally. But it delegates it to that data access object in Java and finds the movie by ID. That's a very simplistic implementation of a data fetcher or resolver in the GraphQL world, and that's what is required to create a very basic GraphQL server. And the expectation is from the movie resolver, from the movie method, the POJO or the object that should be returned should follow the same structure as it is defined in the schema. If you see the movie types from lines 5 to 11 on the left hand side, the expectation is the method should also return the same movie type. Okay. Now, once we look at this implementation, there is a JavaScript implementation using Apollo server, and this is what our GitHub repository actually is using. We are using an Apollo server to create a GraphQL server. It adds the GraphQL endpoint by default. It does all the wiring for you. Again, it only needs two things. One is the schema. If you see line number 1 to 4, we are loading the schema GraphQL, which is defined on the left-hand side of the slide. And it defines resolvers using this, using line number 6 to 10. And I'll talk more about it once we look at the look in detail the app that we have created for our demo purposes. And then you just use the type definition and the resolvers for creating an Apollo server. And that's what you need in the very bare minimum to create a GraphQL server in JavaScript. And again, these are called resolvers in JavaScript. And if you see by convention, these are called data fetcher in GraphQL Java or the Java world. So that's basically what we need to create a GraphQL server. Now let's talk about scalars and enums. We'll get into the details of these scalars and enum definition once we actually start looking at some code in our server. But if you see, I've introduced datetime scalar and enum in the schema on the left hand side. The only thing I added after I add a scalar is scalar coercing, which is called a different implementation. You also need to, in addition, whatever you add to the schema, you need to add it to the server, the runtime implementation also, which is in the Apollo server. If you see, I've added a scalar date time, and the date time implementation has the name, the description of the scalar itself, and some methods. There are three methods: parse value, serialize, and parse literal. These methods are used to translate the string to the correct type internally, and the date type to the string type or to a proper JSON object at runtime when the response is being sent out to the client. Serialize is actually converting it to a string, and that's what will be sent out to the client. And in case of values accepted from the client itself, we use the parse value and the parse literal object. So that's and enums don't actually need implementation. If you see enums, you can just it tries to just auto box it like in regular programming languages like Java or anything. Enums are very straightforward. We saw some like enums coming back as English and Hindi yesterday. We'll see more of it today. Let me see. Okay. So now this is very important concept in GraphQL, which is the resolver itself. How does the query is actually resolved at runtime? Uh, Basically, when we have a GraphQL query, and if you see the query in the slide, there is an example. We are asking for movie title, rating, reviews, comment, and reviewer. The execution starts from the root and it keeps going the next depth as it proceeds. So in this example, based on the resolver we saw, we had a resolver at query.movie. It will try to resolve. It will resolve the movie method. It will call the movie resolve method, and then it will fetch the movie object. For each of the object, there is a default data fetcher or default resolver that is the server adds, and that default data fetcher is basically if the parent is providing you the value. So when it is going on the next level, which is movie.rating, movie.title, movie.reviews, the parent is already provided the data. If the parent is already provided the movie object correctly, it will use that value from the parent itself. If not, it will expect a resolver to be registered to the server at that level. For example, if the reviews was not coming from the query.movie resolver, it will try to see if movies.reviews has a resolver registered. If not, it will just return null. Similarly, it will keep on going to the next level until the leaf node, and this execution is very fast. Usually, all of these resolvers are executed parallelly, so that the runtime execution is asynchronous and it responds in a very timely manner, in a fast manner. So let's look at. Okay, we'll so before getting into the n+1 problem, let's actually go to our application, the movies application, and start looking at some code. I think that's something that we should play around with, because okay, let me start sharing my screen and then we can look at it together. Okay, can you guys see my screen? Someone, please. Okay. And is this screen visible, or do you want me to zoom? Okay, cool. So I will first look at this GitHub repository and explain the structure of the app itself. Okay, so one second. Okay, so let me open the demo app, and if you see, there is a README that describes the app itself. It describes what the server host is, how do you open this studio, what are some of the queries that you can actually use. We'll talk about data loaders, but let's understand the structure of the application. We have a data folder which has movies.json, which is just dummy movies in this folder. And then we have movie service, which is the business logic, which actually does nothing but fetches data from this movies JSON. Then we have schema.graphql, which is the schema definition file, STL file. And then we have the index file, which is the server file, which uses the Apollo server. Now, if I look at the right side of my app, let's start with the schema definition. Let's try to understand that part. So we have queries and mutation in our app. If you can see, there is query and we have the following queries. We have a movies, which gives me all the movies by ID, by language, genre, year, top rated, recent, and search movie. Search movies basically will search the movie using some query string. We'll try that part also. And there are some mutations, which is add movies, update or delete, and add reviews. So very simple application. And if you see, I have a review type which is using a date time scalar, which is defined here. Scalar, as I mentioned, is used for any kind of customization to your non-regular type. A datetime scalar will format the date to and let's look at this scalar also. So it will format the date string to an ISO string, and you can use any kind of convention if you want. And another example of a schema could be an amount scalar, which can format your amount to add a rupee notation or a dollar notation. Usually we use that a lot internally, with commas also. Like you can modify it the way you want. Then we have an enum somewhere. I think I had an enum in this. So we had two enum. One is genre and one is language itself. So we're representing the language and the genre in the movie type, movie input, and also the movie type. Yeah, there's a language and there is the genre. So this is basically the structure of the schema that we are providing to the app, and that's basically what we'll be working with today. Now, if you see the movies JSON, just a quick peek at the JSON is just consider this as a database for now. Some payload was added. Only one of the movies has reviews. It has data about some English movies and some Hindi movies at the bottom, I guess. Yeah. Jab We Met, Barfi, and so on. So I think we have 25 movies in this JSON. And then the movie service has methods which deals with that JSON file itself. And full disclosure, I have not written any of the code in the whole repo. I actually asked AI to write it. So there might be some logic that might not be optimized, or if you ask me details about any of this code, I might not be able to answer this. Or it might take time for me to answer. But the most important file is the index.js. Index.js, like I was explaining, it maps the queries. It has all the resolvers for the queries and the mutation. And if you see this should take you to the movies JSON movie service file. Let's look at one of the files. It loads the movies from the JSON file and it tries to map the movie into yeah, it returns the movie list, and there's movie by ID. Again, it loads the movies and does all that. Now it doesn't do any kind of caching or anything. It always loads the movie from the JSON files. Let's look at more. So step 1, loading the schema file, which is defined in schema.graphqls. Step 2, loading the resolvers for each of the operations defined in the schema. Step 3, creating the Apollo server using the type definition resolver. Plugins is basically some Apollo some Apollo feature which actually opens the Apollo Studio. By default, I have not been able to do that, but I just kept it. We can remove it also. Course, you know what course is. And then there is a scalar, which we just defined in the schema. Anytime you define a scalar in the schema, you have to provide an implementation like this with these 3 methods, name and description, so that the runtime engine of the GraphQL understands how to deal with that scalar. Any questions on the setup? Or anyone trying this by yourself? Cool. I'll proceed. Let me see if my server is running. Let's restart it. Okay. So that is a question. Okay, we use enum just it's like using it to restrict the values. Like enums are used just to make sure that the values are well defined. And if you see, we are using like enums for, I think, language and genre. So it's a list of predefined values, and it needs to match. And if you see in the Explorer also, I think in the Explorer should show up. I guess, yeah, see here, you know, it's basically already a predicted value that might come out from the server, right? It's basically any programming language has enums. The same concept apply here as well. So the app is up. Okay. So let's just start with, let me movies by language. Let's just make sure that we get all the movies in the. So if you see, I'm also using this today. I'm using this control space in the editor itself, which gives me the a way to type my queries. So language is not being used. See if it's giving me an error for something. I guess that's what the error is for. I'll just rename this to all movies. And then I don't need to use this. So I'll remove the variables. Let's hit this. So I should get how many did I get? 25. Okay. Some things are null. So if you see, description is defined as null. Now let me explain a very important concept. In here, description in a lot of the movies are null. Now let's go to the schema, and if you see the schema, this exclamation in the schema on the right hand side means it is not null. Meaning if you have not defined that, it will be an error on the client side as well as the server side. So for example, let's look at it from the input itself. Why is it important in the input? So for example, if I'm querying, let's say movies by language, and I say language is mandatory. If you see the schema of movies by language on the right hand side, language is actually mandatory, which has an exclamation. So it is a non-nullable input that you want to ask the provide. And let's do language. So if I don't provide it, this will be an error, and I will not be able to query this. Let me just copy it. See, and that's one of the advantages of GraphQL, that you will catch these even before even executing the query. We don't have to go to the server. Now I'll explain a problem. So input set is very helpful. It actually validates your query. For output, there is a problem. I'll share the problem once let's just do. Okay, language is enum. So enum, I think. Okay, so if you see because I have defined it as an enum, it gave me suggestions on what their value should be. I didn't have to actually predict what value I should provide. I could provide in capital case or no, right? So I think, so let's query this movies by language. So we have 16 to 25 as Hindi movies. You can validate in the JSON file. But yeah, we got that. Again, demonstrating the beauty of GraphQL with the which solves for underfetching. We can query both of them together if you want. Now I was talking about the null, not null exclamation in the output type. So let's try to do that and see what the server what it behaves like. So movie, the description was found to be null. So this is the description. I'll make it not null, and I'll just restart the server. Here, I have restarted the server. Let's see if the schema, this is able to refresh it. Okay, so this screen means it is able to fetch it. Same queries, I'm not changing anything in the query itself. What I'm going to do is I'm going to ask for all the movies, same thing. And I think, did this fetch description? So it didn't update the schema yet for some reason. Here it should show up as not null. Usually refetch. Language. Movies. Okay, so it's something, the schema is not getting updated. Maybe it's caching it. Movie, yes. Reviews. Okay, I did update description. Okay, so I am not updating the right file, it seems. Is it here? Index. Okay, it's loading the right file. Okay, now it detected that. Let's see if the server picks it up. Okay, description is coming out as not null now. If you see the server updated itself on the Explorer, and if I do all movies now, you see there is an error, cannot return null for non-nullable field movie dot description. Now the problem here is, because we've defined the schema as not we've defined description at not null, the GraphQL engine at runtime expects it to be not null. So even though the other fields were present, you actually lost those information because the validation happened where the response is not matching uh, the response is not matching the schema. And if I remove the description from here, I should be able to fetch all the information like it was. So a very important lesson here is to use that not null variable in the output very carefully. It defeats the purpose of partial responses in GraphQL. A lot of things are actually not null, but if you know, like something like enum is never going to be null, right? Because if I see my enum language, I have other also, so I'm not expecting that enum to be not null. But something like which is something like description, which is very common to be null, you should keep it as uh, nullable. So let's just restart. I don't know if we need description, but let's see if the server refetch. Okay, it went away. Let's do. Okay, so it started working again. Any questions on this until now? Did everyone understand the app setup, or are you actually working alongside me on this app itself? Cool. Cool. Let's understand the scalar itself. So scalar, we've defined date time, and we've defined some fields as scalar. Let's see what field is created at and updated at. Let's look at created at, updated at. Let's try to do that here. I'll comment this out for now. So you can keep comments in your query also if you really want. So if you see this is actually coming with an ISO format because we have implemented a scalar coercing. Let's try to change that as well. Okay, not this. We've implemented a scalar coercing here. I don't know if there is another method. Anyone knows the method for any other string? To date string, maybe local date string. Let's do this locally. I don't know what this is going to return, but okay, let's try this. So I changed this to be not ISO string, and if you see this defined in a different in a similar format in the GraphQL JSON file, and I change the format. I'm not sure what it will come out. I've not tried it. So let's just restart it. Okay, let's run it. I believe this changed. 1321. I don't think it changed. Maybe 14T. Let's use a different coercing. Two. Let's try two date string. And you can play around with this also. So let's just look at. Let me just validate if it took my changes. Yeah. So let's look at. Okay. I think the coercing for this is probably not working as expected. Maybe we need validate date. I think it is because it is parsing it from the JSON string directly. That's why this is not working fine. But the serialize method should give you the this is for input, I guess. But let's see. To date string literal. I think this one will probably give you. Okay, let's try this. I'm not sure if this will work though. Yeah, something is not working. I think one of the methods is not working correctly. I will fix this scalar, but these three methods needs to be implemented in order to write any kind of customization. I think it's still using some kind of date format. Okay, so let's look at one important aspect of GraphQL, which is the data loader itself. Let me actually write a query which with an alias. So let's say I want to ask for movie and the movie ID is, I will not use variable, but I'll use one, and maybe let's do title, rating, description is huge sometimes. Let's do description. And I want movie 2. So if you see, there is an error in the query itself where there is a conflict. I cannot have two movie types in the query, because when you return the data, which movie type will be returned? Will it be the movie type 1, or will it be the data for movie type 1, or will it be the data for movie type 2? So the way we get across this is use an alias. So you can just use an alias, any string as an alias, and do a colon. So you distinguish the same field with two different aliases, and then you can ask for multiple datas at once. If you see 1 and 2, let's do some Hindi movies actually. Let's do 19 and 20. Okay, good. So the concept here is you can actually batch things together into a single request with different arguments and use aliasing to even query the server for the same operation with different arguments. Now imagine the same thing in REST. In REST, you once you want to make ask for multiple objects from the backend, you either make two calls or you create a special batch operation which takes a list of IDs and returns a list of object, which is again like a very tightly coupled contract between the client and the server. One other concept I would like to share in here is this one of the query optimization technique. If you see in this case, I'm repeating the whole object or all the attributes again and again. So if I have a lot of movies, I will be repeating all of that. So let me just add a new concept of GraphQL here, which is called as fragment. Fragment is a reusable query. As the name suggests, you can have a fragment, define whatever you want. Let's create a fragment description. You can add and then in here you can use the fragment instead of repeating the whole payload again and again. That is one of the query optimization technique which is very commonly used in GraphQL. If you see here, I can just refer my movie, and there is syntax for fragment, my movie, and then any number you can, if you want to add it to, let's say, all movies also. I think it was movies. Oops. So you can add the fragment here also. So you can use fragment across multiple operations and you should still be able to get the data. Any questions on alias and fragment? This is very important concept which is very popular in the industry that people use when they create dynamic queries and dynamic want to ask data from the backend in a dynamic fashion. So here is a fragment. Here is the syntax of fragment. There are other types of fragment also which are used when you use unions and interface, but that is some concept which is which you can read about. When the return type is going to be union or interface, you need to define the fragment. Inline fragment, these are called, but these are like reusable fragment that you can use in your query, and this you can imagine can keep growing, right? If you see it actually highlighted everything, and I can just keep increasing my fragment, and it should, the data should now replicate that fragment all over the place, in here, in the cover images here, in the cover images everywhere else. So that's how a fragment looks like. Now let's look at what happened in here, and let me just restart so we can look at the logs. Okay, I've restarted the server. I wanted to look into the logs, so let's keep this example movie 1, movie 2, or we can just say, because we know the ID now, tzp or znmd, and let's query that. Alias can be any string, anything that you can use to identify your payload will be an alias. If you see in the response, that operation movie becomes alias, so tzp and znmd is coming as alias. Now, close attention on the logs itself. Get movie by ID 19 and get movie by ID 20. It is loading the JSON file twice for fetching because so there is only one request that went to the server, right? Both the requests actually loaded the file from memory, parsed the file, did an IO operation, and then tried to find a movie with an ID 19 and movie with the ID 20 separately. Now the problem with this approach is, let's imagine your this loading of file is actually loading from database. Now, even though your operation is coming from single query, both the operations are coming from single query, we have unoptimized the loading from the database downstream. And I will switch to my slides to share that concept here. So can you see the slide on the left hand side? Oops, yeah. Can someone confirm, please? Cool. So see this example. In our example, when we are making a movie service, we have a resolver registered at the movie itself. And then what the resolver is doing is querying the movie DB, let's say an example of JSON, for each ID. And now the resolver is loading and fetching data from the DB multiple times. This is very unoptimized in terms of a real world system because you can't control the number of aliases that the client is using. Your API, by the nature of staying in the GraphQL spec, you are opening up your API for batching operations, meaning a client has the ability and the flexibility to query multiple movies at once. But on the server, you're not using the GraphQL benefits or the GraphQL tools to optimize your network calls to the downstream or optimize your DB calls, right? That is going to put a lot of load on your DB if you keep doing that and not optimize the DB calls. One of the most important concepts, and that is something called as the n+1 problem in the GraphQL. Even though the GraphQL server, the movie service received only one query, it resulted into n calls to the movie DB. So that is incoming one request, outgoing n request is the n+1 problem. And there is scope for optimizing this problem at the server, at the implementation. And GraphQL actually provides a beautiful feature called as data loaders. There is a concept of data loaders, but before data loaders, I'll also explain the n+1 problem in the context of array types. When there is array, imagine there is an array type returned for all movies. Each array has has 100 movies. Sorry, the array has 100 movies. And if you think about, if you apply this concept on the way resolvers are executed, any of the resolver itself can query the database. So for 100 movies, the resolver, if it is querying the database, it will result in 100 calls to the database, which is very bad. Like for example, let's say the review DB is review is a separate database or separate table on its own, and the review resolver is separate. Now for 100 movies, each of the movies, the review resolver will be called, and the review resolver will actually result in querying the review database for 100 times. It gets worse and worse the more nesting of your types you have, the more number of outgoing network calls or outgoing downstream calls your system will execute when you're in the GraphQL world. So it is very, very important to understand that in the GraphQL world, the nature of your resolver, the nature of the schema, and the nature of your downstream or the database that you're interacting with. And GraphQL actually provides a provision called as data loader, which helps you to aggregate the outgoing calls, or in a sense, delay the outgoing calls before you can query the database. And it's a very simple concept. Instead of writing a resolver, you can write a data loader and call a load method on the data loader with the correct argument. And we'll see that is an example on a different branch, but you can query it. And then that data loader will, what it will do is it will be called with all the IDs together. And your job in the data loader would be to take all the IDs and make sure that you only make one call to the DB. So you will get access to all the IDs. In this example, you will get access to ID 1 and ID 2 together in the data loader as a list. So the data loader will by default batch it for you and provide it to as an array operation. And then you can just make sure that you coalesce your call to the outgoing DB and get the data all at once. Let's look at that as an example. If you guys are following the GitHub repository, I have a branch called as data loader in that example, and we'll look at the implementation of the data loader, and we'll also look at how it actually is optimized. So I will switch to the branch, suggest you to do that as well. Let me just do GDW. What did I do here? Okay, this didn't work, so I'm not going to ECM. Okay, cool. Let me start the data loader server on data loader branch. Okay. Are you guys able to get that? Like, I don't know if I pushed the branch. Let me check quickly. Okay, so there is a data loader branch. It has the data loader implementation itself. Let me see if I can. Oops. Cool. I think this is good. And yeah, this console logging and stuff. Cool. So the server is ready. The studio, let's see, the studio fetched it. Okay, the studio seems to be fetching. Once, let me execute the query once just to make sure everything is working fine, and then we can look at the implementation itself. Okay, so here, if you see the logs, the query, these two execute, and the resolver itself, that the query received with 19 and 20. Then the batch loading happened for 1920. In the batch loader, 19 and 20 IDs are together. The file is only loaded once. Okay, that is the important concept. And by loading the file once, it means it only queried the DB once and batch loaded 2 movies. Let's look at the quick implementation, and we'll make sense of the logs itself. To implement a data loader, you need, let's see if I have it in the doc. Okay, I think it's here. Let's go to data loader. The demo app. Yeah, so I think I've explained the data loader in here, but the library that we use for data loader is data loader itself. It's called data loader. The concept is you implement a data loader. The data loader will have always receive an array. If you see in the data fetcher of the movie service, not movie index JSON, maybe index.js, the data fetcher or the resolver, it takes a single single ID. Wait, this has not been updated, it seems. Load movies. Let me just check the implementation is correctly. It has to be correct because it's working fine. Okay, movie service. Data loader used. Get all movies. Yeah, so this is going to be a list of IDs that you will always get. Then you load the file using the movie service only once, and then for each ID, after loading the file, this is the important part, that you load once and you only use it in the same method. So although you are getting n number of requests, the file will be loaded only once, which is in the data loader. In the regular loader itself, load movies, fine. In the regular loader, regular resolver, you actually don't load it once. You load it more than once because your movie by ID will actually load the file again and again. So let me go back to it and let me see. I think this is not getting updated for some reason because the load method of, let me see the commit. Data loader. Okay. 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 So I think this should be. Oops. Yeah, it's updated. So the data loader should actually be used here. Yeah. I think I have a little bit hiccup here where the movie loader is not loaded. Probably there's some Git issue happening here, but I don't know why it actually worked because I'm not seeing the changes here. But let me share something here. This should have a good example of data loader. So you export the data loader, and in your resolver, you just use the data loader. Wait one. Yeah, this is a load method. You call the load method in your. Let me just try see if this fixes it. Okay. I will commit the code once I verify it correctly, and then I'll publish the data loader code maybe right after this, and share the example on the Git. I think there is some hiccup on my local itself. I think there's one file which is not being committed in the movie loader, but I'll commit it shortly. Sorry about that, but I think I wanted to explain this concept of data loader, that using this data loader library, you have to call the load method from your resolver and not actually load it from the file. And once you call the load method with ID 1 and ID 2, it will actually call the data loader with a list of IDs 1 and 2. And that's how the data loader is able to combine all the requests into one request, and then you can deal with whatever backend that you're dealing with. In this case, it's a JSON file. It's only loaded once, and then that's it. You load the file once, you query all the, you fetch all the IDs that you can fetch from that loader. And once you return a list again, and I think if you see this, this is going to be a list because you're using a map function here. Once you return, your input is going to be a list of inputs arguments, and the output needs to be a list of movie objects. Once you meet that contract, your data loader will start coalescing the data correctly. And I think this, yeah. So if you see here, the code is working as expected, but I am a little bit confused on why my editor is not showing the correct code. So I'll try to fix it. I'll commit the latest one. I think it's somewhere it is stashed in my local machine, and I'll be committing that. Okay. Yeah, here you go. I think this is the, okay. Here you go. I think it was somewhere stashed on my local. So if you see this, all the data fetched, especially the get movie by ID, I've changed only that. Get movie by ID is actually calling movie loader dot load, and that's something that I wanted to share. This one line is very important. I'm not calling the movie service dot get movie by ID here. I'm calling the movie loader dot load, which is what is actually activating the data loader. If you see, this is the movie loader coming from here. I'm calling the load method. Load method will ultimately call this with a list of aggregated IDs, and that's how data loaders actually work in GraphQL. Again, I don't know why this editor is behaving weird for me. I'll probably close it. Don't save. Don't save, and then let's see if I reopen it, it shows up. Yeah, it's showing up on a reopening. So if you see, there is a load method in here, which is actually using the movie loader from this class, that the one that we were looking into. And instead of a regular resolver, we use the movie loader dot load method for a resolver, and that's how data loader usually work. If I use get all if I see the get all movies method or any other method, let's look at movies by year, right? Let's look at that method and let's try to use that. Movies by language is there, right, too? Yeah, let's look at movies by language, one with English and one with Hindi, and see what the behavior is, right? Because that doesn't have a data loader. This is actually querying the movie service directly. So it will load the movie twice, is the expectation. Movies by language, and then first language would be English, and I'll not use variables for simplicity. Hindi, and I'll use English, and I'll just use the fragment. Oops. Okay, so Hindi movies as the alias, and then I'll use my movie, and I'll use English movie as the alias, and my movie in here. So once I hit this, look at the logs now. So we got the data back. I think if you see here, we got the data back. Hindi movie is coming back, English movie is coming back, and here, because I don't have a data loader in there, I query language by fetch movie by language using Hindi. It reached the movie service once. It loaded the file once, and it fetched 25 movies. Loaded 25 movies and filtered the Hindi movies. Then it did the same thing for English, and it loaded it multiple times. But if you see in the previous example, when we were asking for when we were using a data loader instead of data fetcher or resolver, we were able to load the JSON file only once from memory, which is this example, right? It actually came, if you see the log here, it actually came here, batch loading 19 and 20, getting all the movies from this method only once, and loaded those 25 movies, and then it loaded found the movie 19 and 20 from that one instance of the movie itself. This is a very important concept in GraphQL, because this is actually used in real world systems where you don't want to overwhelm the backend system to fetch multiple times and run into an n+1 problem. Highly advisable to use data loaders instead of resolvers from the get-go, and try to see if you can optimize the n+1 problem. There is also caching implemented in the data loaders. If I can just make it true, I'll just show an example of caching itself. So I just made caching as true. And if you see, let's go to the example that we were doing with, because we have data loaders for movies by ID, tzpznmd, and then let's do movie, and then we can do, oops. Okay. So I'll do ID, and then I'll do ID 19, it was. and then I'll do okay, and I'll do ZNMD, which is movie ID 20, I guess. What is the problem here? Okay, so I fetched movies 19 and 20 once. Let me fetch movies again. It actually did the caching was true. GST. Okay, something is not saving my file. Okay, let's see now. So we fetch it once. Second time, I didn't have to load the file altogether. If you see, it responded with the same data, but did not actually execute the batch loader. So it caches by default. This is a very simple version of caching, but you can implement your own caching key and stuff in the data loader. Let me change the movie to 21, and if you will see how it caches based on the argument itself. I just queried again, and it only batch loaded 21. In the previous example, first time it loaded, it was loading 19 and 20. It second time we loaded, it didn't even execute the method. It cached it and returned the value. Then the third query we executed with 19 and 21. It only loaded the movie with an ID 21. So data loader is very important and highly used concept in production environments, and it optimizes your GraphQL server to another level. Any questions on data loader? I think there was a lot of confusion while I was setting up my environment. Also, this is very important, and I want you to take away that data loader is must when you actually implement a GraphQL server in a real world system. I'll take a break and open up for questions for data loaders in general, and then answer any questions related to that. So no questions. Should I continue? Any questions on the implementation itself of the data loader? So the cache true is basically a default caching that data loader provides. You can implement a complex caching because usually the IDs are different, right? Like in this case, we use the caching we use caching using a movie ID based on the input arguments, which is the default caching. But you can use any kind of caching on your own end. The keys can be defined by yourself. The any kind of customization to the caching can be defined by yourself, and then depending on your use case, you can customize the caching for your to fit your use case. In some cases, a complex key might be a caching like title, etc., etc. Right now, it's just using the default caching that is provided out of the box from data loader. It's highly advisable to use distributed cache and not in-memory cache. In real-world system, use Redis or something like that, so that all the servers can use the caching system. And you can actually plug in your own cache using data loaders. Let's just look at caching in here. Here, see. Yeah, so this load method is going to be very important when you call data loader, and you see that it can take a cache map, LRU cache of your own. It can do any kind of, you can do any kind of customization with the cache itself. Cache key can be provided that you want, cache map, which can be a map or something like a Redis cache here itself. Right now it was caching based on whatever was the input to the load method. If you see the load method, I think here we were passing the ID as it is, so it was caching based on the ID. But you can use anything and more complex stuff in your user ID, etc. You can use more complex caching that you the way you want. Also, I want to call out, sometimes things get tricky with data loaders. For example, be very careful when you do cache equal to true, because once it starts caching, you will not be able to fetch latest data from the database. So for example, in our example, if let's say for some reason the movie database is actually been updated from the backend itself, you will not be able to get the latest data because data loader is caching based on the ID. If the ID 19 and 20 in our example are updated from the backend, you will not be able to get the latest data unless you actually clear the cache of the batch loader and start listening to the database events. Then only you will be able to fetch the latest data. So implement caching with care. You might be sending stale data to your client if you don't implement caching properly. But uh, caching is one use case of data loaders, but batching, which is very important, batching is one use case that you should definitely do. Caching might get a little bit tricky, but batching is something we should always do in your GraphQL service. If no further questions, I will go to the next slide or the next concept. I think we have 12 more minutes. So we did data loader demo. You should be able to pull in my branch and try out data loader by your own, and then also try out registering or using data loaders for, let's say, movies by language or movies by genre or movies by year. You should be able to get those things easily. Just write a data loader, an optimized data loader. So the next important concept is directives, and I particularly like this, and this makes GraphQL very powerful and customizable in general. Directives are decorations on the schema or annotations on the schema itself, which helps you to change the runtime execution or behavior of the resolver or behavior of the runtime engine itself. It can provide validation, more sophisticated validation on your resolver in a very streamlined fashion or standardized fashion on the server. It can also do uh, authorization. Usually, if you see in the example on the left side, I have 4 directives, namely line number 15 to 18 is the way you define directives. I am defining @key, @private, @translate, and @ODZ directive. ODZ, very straightforward. It can be used to implement authorization policy using a role-based access. The movie, if you see line number 2, is using an authorization which is allowed for admin and user, and users is only allowed to and visible for the admin role. So using directives, you can decorate your schema and change the behavior, add any kind of validation, and we'll look at these examples tomorrow on how to use directives. Another example of a directive is line number 6, where I am marking the ID as private. So at runtime, you can implement the execution of the directive as a private implement the execution of the private directive to behave like it is obfuscated, or you just send some masked value to the client rather than sensitive information. Similarly, description, I have added a directive called as translate. So you can actually use the language on attribute in your movie type and translate the description to the language that the movie was created in. That way you can use some kind of generative AI or some kind of tool behind the scenes to translate it, so your API becomes more localized. So for example, in case of an English movie, the description can stay in English. In case of Hindi movie, the description can be translated to an Hindi text. Similarly, date time, I have a role of Aussie. The visibility for the date time field is Aussie. Role as admin. Now, if you see, directives can be used at any level, not just at the operation level where you define resolvers. It can be used at the leaf node itself, and that you can modify the behavior of the system at any level. Directive key on line number 5 is actually one of the most important directive in today's world used in federation. We'll learn more about federation tomorrow and what it means and how it actually works. But that is one of the most powerful directives that we have in the open source community today. And people usually create directives to extend GraphQL spec, things which are missing in the GraphQL spec itself, and create custom libraries based on these directives, open source libraries actually. If you see, the key directive is defined on a type definition. It is not defined at any of the field or the operation level. So directive can be defined on object definition or field definition. Enums also, anywhere you can think of, directive can be defined. There are directives at the client side also, and there will be directives that are inbuilt into the GraphQL specification. Some of the directives are skip, include, deprecated, and specified by. You can look at these, like these are very popular directive. I'll share an example of skip. I think the Apollo Studio should support skip as well. Some of the more powerful directives are defer and stream. Defer is used to split your query into two parts. Let's see if we can get defer supported. And stream is usually used to get continuous stream of data from the backend. Key required and extends, again I said, like powerful directive used by GraphQL Federation. We'll look at it some of them tomorrow. REST DB, I just added it there, is basically a lot of startups in today's ecosystem use directives to create custom GraphQL connectors. They can translate your REST API to GraphQL using the REST directives. They can have direct connection to your SQL schemas or SQL types using the addDB connective. There's a lot of startups popping up just translating your tables to a GraphQL schema and providing CRUD operations on top of those. So example, think of a movie table in a MySQL DB, right? There are startups which just takes the table, create the movie type in GraphQL, auto-generate it, and create these get movie operation, get movie by ID operation, then mutation. They can create movie, update movie, delete movie out of the box by just annotating with a DB directive and giving all the required information to the directive itself. If you see, directive has arguments. You can have any number of arguments and you can create your own directives for your own customization that you want on the server. And that's how you actually extend GraphQL or add customization to your runtime engine. Like it's changing the behavior of the system at runtime. We'll see an example tomorrow. Let's see if the skip directive actually is, yeah, skip directive. And if I can just say true. So skip is a client-side directive. There are client-side and server-side directive. I don't know if it is defined here somewhere, but okay. Let me just change this to a Boolean. It's so strict. So skip directive can be used by the client side to conditionally modify your query. A lot of people use it for keeping a very giant query and conditionally asking for a particular movie based on the variable itself. So imagine a JavaScript code actually creating this variable, and I can just call it condition for Z and MD, and this condition can come from a very complex code that doesn't want to show Z and MD, and then I can just change this, and then I can do this. So I can use a variable to refer in the query, and in the directive I can use the reference of that variable. Now that variable can come from a very complex condition in your client code, and that can make your client more flexible. Then there is include. Include is probably a different, I think I can do include. I can do include also. Similar to skip, there is an include directive. It will be included only if the condition is true. So if you see this, I was able to include it, and keep looking at my console also, it's cached. So I'm not even loading the file at all. And then I can do skip on this, and then I'll just say false, true actually. So I'm referring to variables. You can refer any number of variables in your query, and you can use any number of references here. So I have skipped TZP and I have added included ZRMD, and I can make it false. I don't know how it will behave. Maybe it will not make the query. Yeah, so it didn't get me any data. So that's basically skip and include are special client-side directives available outside of the box. Directives, as you see, can be applied to the queries also, and you just need to define it in your schema for the client to actually use a directive on the Explorer. Now let me go back to the slide. And you can think of any customization. These are just examples that I'm sharing of the customization usually we do on the server side, but you can think of any customization you want to do. You can use directives for doing that. Okay. So best practices for GraphQL schema. Basically, you have to design your GraphQL schema for consumers or your clients and not for your database. Don't have to map it one-to-one to your database, although that's the standard practice that a lot of platforms use. Naming convention is very important, and I'll talk more about this tomorrow when we talk about federation, why it is important, because there's a lot of conflicts that may occur in the GraphQL itself. For example, in my schema here, I cannot have a type movie and an enum movie in the same schema. This is an error in the GraphQL world. I cannot repeat the same type again in the GraphQL world. So these are things that are not allowed, and GraphQL spec is very strict in terms of redefining the types. And it is applicable for any type. So scalar date time, if you have in the schema, you cannot have a date time object or date time enum in your schema. So GraphQL naming convention is very important. Non-nulls with care. We just saw an example today on what non-null values actually can lead to. Very thorough documentation as field level. It's very important that you document it. And the more and more we are moving to generative AI, I think the more important your documentation becomes an agentic AI, because the agent, not just client, needs to explore this schema that you can see via the explorer and understand what your each field is by the nature of documenting the types and fields in your schema. There's also agentic use cases which can actually be queried or by the agents, and the agents can understand the GraphQL schema and imagine an agent actually automatically creating a query whenever it is required. So for example, if you ask hey, give me a movie with the title that starts with etc etc, an agent should be able to figure out from your from your schema itself, using introspection, what API I need to call and what data I need to fetch. Right. So it's very important to document it to get all the benefits of the GraphQL. And in today's world, you can actually create documentation also using generative AI. Pagination is a standard concept in REST. In GraphQL, there is a special spec called relay, which can be used for paginating your types. It's the same concept. You'll have a limit argument and you probably have a offset to paginate your list. Data loaders, we saw a very good example of data loaders where it's used for batching. Introspection should be disabled in production. The security, it's a security requirement that you should disable introspection in production, because once you expose the entire schema, there's a lot of sensitive information that the attacker can have. Error messages needs to be very clear. If you see, I think my example, I don't have clear error messages. If there is, let's see, let me just do 28. Oops, let me just do include if true. Okay, null, right? I did not, it was not found, but it should have also told me that, hey, something, it should have also resulted in an error or something like that, telling me what the error message is all about. In REST, it is very it's all about status code that figures that provides that information. In GraphQL, it should be the error object that tells me the error object should be present. And I think I just do 28 like this, maybe. Okay, it works because it typecasted. Cool. I think the last message, avoid versioning. GraphQL by default provides a very good support for versioning your APIs using this @deprecated annotation. The @deprecated annotation can be used on any field. If I show you, let's deprecate @created and reason use updated instead of created is it review input? No, let's put it on our type. Quick example, and let's see. I have to keep making sure my service restarts properly. Okay, so if you look at the Explorer, I added @deprecated annotation to the movie type for @updated field. Okay, I did it for updated. Let me do it for created. And I asked it to use the updated field rather than created field. If you see, I didn't have to define the @deprecated anywhere in the schema, because like I said, it's an inbuilt directive that is already part of the GraphQL spec. And let's go to the studio quickly. And let's try to query, what is it called? Created @. See, because I annotated my schema with @deprecated, my studio, and automatically it started complaining or showing me a warning that I'm using a deprecated field, which I should not be using, and with the message that I just added to the schema. So it's important, right, to have proper documentation, and you can even have a very well-defined reason on the like a paragraph or something on why it is being deprecated. It's not that it will not work. It will work. Why it didn't work? 2020. I will get the field, but it is not, it is discouraged. And that's how you basically version your APIs. You start marking fields deprecated. That gives the client enough time to change this created. So your messages was like, hey, stop using this, use updated method at, and that will get rid of that error. And then once you verify through logs or through some kind of monitoring that all the clients, none of your clients are using created at, you should be able to deprecate or remove it from the server itself. Like then after that, you can just delete this and making sure your clients, none of the clients are affected by this deprecation. So that's how you usually do versioning. There is nothing called as V1, V2, V3 like you have in REST. Usually deprecate or version at a very field level, not at the API level itself. You can also deprecate operations entirely. You can add deprecations at movies by ID, etc., etc. There's a very standard practice of using deprecation in GraphQL. So any questions so far? I think we went over time, but that's all I had. But I'll leave it open for questions, 5 minutes. And if you have any questions, please post on the channel. Shares will be shared after this session, day 2 slides, and then we'll share slides tomorrow also. I would like the LetsUpgrade team to comment on it. If what is the timeline when we are looking for sharing slides? Okay, I don't see any questions posted. So I am assuming we can end the day today or end the session. Cool. I'll drop off and thank you for your participation today and your patience while I was dealing with a few issues. I'll see you tomorrow and have a great day.